You're not just looking at any ordinary tunnel. This is the largest tunnel in the world, an engineering marvel that spans a breathtaking 50 kilometers beneath the ocean. Often hailed as the seventh wonder of the world by experts, it stands as a testament to human ingenuity. What makes this tunnel truly remarkable is its design and the sheer scale of its construction. Over 13,000 workers toiled in incredibly harsh conditions, digging through terrain burdened by the immense pressure of the sea above. This monumental project pushed the boundaries of what we thought was possible, transforming an ambitious vision into a reality beneath the waves. A single miscalculation may fully bury personnel and equipment in this underwater tunnel, and that too in a couple of seconds. At the closing of the previous ice age, about 13,000 years ago, observers, that is, it retained the boundaries between current Europe and England. Their separation developed from this section of the ocean that is today referred to as the English Channel. Although it is currently relatively large, this canal is beginning to become incredibly small. Furthermore, it is currently only around 33 kilometers between England and France. Throughout history, there have been several attempts to close this imbalance. However, these attempts were abandoned after many deaths, as technology might have been very limited at the time. But as the 20th century was nearing to a completion, technology was advancing quickly. Then, too, the concept of creating a land bridge between England and France was studied. During the 1980s, larger machines could be constructed. Apart from the machine, there was also the challenge of persuading England. Indeed, the English Channel's frigid waters have historically offered England a major advantage over its rivals. Napoleon to Hitler, because of the harsh surroundings surrounding the English Channel, England maintained an advantage over several of its rivals. Hitler, a native of the French town of Calais, undertook a clandestine operation to excavate an undersea tunnel during World War II with the intention of capturing control of England. However, this initiative was never able to take off. Well, following the Second World War and the fall of Hitler, Europe began to undergo considerable transformation. Business started to prosper, and affluence was seen everywhere. Previously adversaries, France and England started trading commerce over the English Channel. After some years, both countries resolved in 1986 to remove this barrier and welcome England back to join the European Union. Strong marches against this decision occurred in England since so many English people were proud of their nation's island sovereignty. After protracted conversations that lasted for several months, both countries decided to build an undersea tube. It was also known as the Channel Tunnel, which a lot of people nicknamed the Eurotunnel. It was agreed that crews from England and France would excavate the tunnel from their respective sides. Every tunnel segment's center points will also unite. The project looked like a massive flop even before it started. Constructing a 38-kilometer-long tunnel beneath the sea div, no engineering business would dare attempt such a venture. /div. Ultimately, the arrangement was struck that 11 engineering firms would collaborate to market the project. Prior to the finalization of the Channel Tunnel's design, it was important to identify the type of transportation that will traverse the tunnel and its beginning and terminating points. Following a mutual agreement, 3 tunnels were built, one for each of the railway loops that connect England and France. 2 terminals will be placed in the English town of Folkestone and the French city of Calais. The tunnel's overall length will be 56 kilometers, including the 38 kilometers that make up its submerged half. In 1986, building on the Channel Tunnel finally began. The engineering team encountered their toughest obstacle when they discovered the tunnel boring machine, sometimes known as TBM, as up until now, no project of this type had ever been built. Because of this, no TBM with this exact diameter was available. This TBM machine must first be designed from the ground up. The Robbins Company was commissioned to create this unusual tunneling device hundreds of miles away in Seattle, Washington. Their area of competence is the manufacture of boring machinery. When completed, this huge machine will be 800 feet long and weigh 1,500 tons. It will feature a 50-foot diameter and several sharp-edged tungsten carbide blades on its front. Because of the hydraulic legs connecting to it, it will progress. A conveyor belt fitted within the machine will remove garbage and crushed stones. By doing this, the debris will be moved to the servicing train, which will remove the items from the tunnel. This tunnel boring machine was a miracle in itself. The archaic practice of tunnel blasting through mountains. On the other hand, this computer provided significant help to coders. However, there are a range of dangers and difficulties associated to this operation. Should water penetrate during the 250-foot underwater drilling, the pressure would be so extreme that the man and the equipment would be consumed in an instant. The scan revealed that the bottom on the English side is covered in a layer of chalk. This will prevent any leakage of water into the tube. On the French side, there are a few seabed fractures where this TBM will not perform properly. It was determined to individually develop a new TBM in order to remedy this. In addition to tunnel boring, a submersible will be used for this. Building this machine came with a new challenge. It had to resist water pressure similar to that of World War II submarines. How would you get it down 200 feet? In order to attain this purpose, the machine was disassembled, and each part was taken out one by one from underneath. The thing needs to be buried and then reassembled. It took several months and millions of dollars to complete. 2 years have passed since the project began. Finally, development began on both sides in 1988. To get rid of that much dirt and rock debris was a huge task in and of itself. The equipment could cut 750 square feet of stone in a single day, and in an hour, approximately 2,400 tons of debris were piled up. Under the Shakespeare Cliff between Folkestone and Dover on the English side, the wreck was repurposed into Samphire Hoe, a national park, and as a result, it protrudes somewhat from the coast. The debris that was collected from the French side took the shape of mud. It was utilized to build an artificial lake by pouring it into the Fond Pignon Valley next to Sangate. A big amount of items was being taken in addition to the large amount of trash being removed from the tunnel. Layers of chalk and loose rock required to be cemented simultaneously with the tunnel boring machine's TBM progress, since the tunnel would be impossible to block if the ocean above made place for it. For this project, spherical concrete slabs the same size as the tube were being fitted. This concrete is even stronger than that used in nuclear sites. The reinforced steel channel tunnel requires roughly 750,000 slabs of concrete. One complete full-sized concrete slab weighs 4 tons. That means that with this much concrete, 8 structures the size of the Burj Khalifa could be created. They were carried to the tunnel, where a special apparatus was anchoring them into position after being put onto the service train. After a few weeks came months. The tunnel was going slowly from either end. Everyone was looking forward to the impending crossover of these 2 tunnels with considerable enthusiasm. It was actually extremely tough, despite what you might see and hear making it sound simple. It is evident that if the 2 TBMs are not relocated to the right positions, the 2 tunnels will never link beneath the ocean. To overcome this difficulty, laser beam guidance technology was being employed. One laser was attached to the English apparatus, while the French gadget possessed the other. Wireless communication connected the 2 navigation systems to one another. Every time one of the machines moved, the guiding system prompted the main computer to correct the head of the boring machine by deploying a hydraulic jack. Both tunnels realigned as a result of that. Whether or not this mechanism for navigation was operating to validate this, both machines will be shut off in the last 100 meters. Subsequently, a steel rod will be transported to the other side in order to confirm the precision of the tunnel placements. At last, after 3 years of relentless monotony, the day had arrived when the gap between them was only 100 meters. And as per the plan, a steel rod was sent through. The difference between the 2 tunnel placements was only 10 inches, which is within the permitted limit. Now the technical team faced their most hard and demanding project to date. It was vital to have one of the 2 TBMs commit suicide. Yes, assuming that 2-foot-thick concrete slabs were erected in both tunnels. The diameter of the tunnel has been shortened from 50 feet to 46 feet. The boring machine, or TBM, likewise had a 50-foot diameter. After the process is over, a 50-foot machine cannot get out of a 46-foot tunnel. As a consequence, it was found that the answer to this issue was eliminating one of the units from the path, what we engineers term suicide via mechanical means. In this way, England's TBM was sacrificed. It was skewed because it fluctuated its angle in regard to the ground. After dropping several hundred feet, it was abandoned there, where it is still buried today. At this time, the building phase came to a close when the French TBM carried on and eventually reached the English tunnel. And the French TBM was carried out and disassembled when they arrived. Now, one would question if the English TBM might have been taken apart as well. What made it go buried then? In truth, the cost of disassembling the boring machine was equal to its purchase. It may be possible to design an entirely new computer for less money. For this reason, the firm first determines which alternative will result in the lowest loss. The decision of whether to remove it or bury it permanently is determined in light of this. For the first time in 13,000 years, there was going to be a land link between the two nations. The final layer of chalk was personally smashed with a jackhammer by one worker from each nation because there were so many workers for this occasion. For the media event, they also swapped flags. The ice sheets that tore them apart thousands of years ago eventually brought England and France back together. A lavish feast was organized to mark the incredible performance. Years of labor, accompanied by sweat and toil, ultimately paid off when the final chores were performed. The Channel Tunnel formally opened on May 6, 1994, provided the project's associated expenses are modified to reflect the revised date. It will consequently be £12 billion, or 190 million rupees. At its busiest, the Channel Tunnel project employed roughly 13,000 workers. Tragic incidents that occurred during construction took the lives of 8 persons. There are 3 tunnels in total, 1 small tunnel for emergency use and 2 larger tunnels for trains. Presently, the 60,000 passengers who use the tunnel every day are joined by 4,600 trucks, 140 coaches, and 7,300 vehicles that are parked in the freight train and used for tunnel transit. I'm hoping this movie will be pleasant and shared. Thank you so much for your lovely compliments. I shall see you in the magnificent future video.